Alright, welcome back. Now, so far we've been looking at this way of expressing the amount of solar radiation that we're receiving, and we said one way we could reduce the amount of solar radiation, that is, we could have solar radiation management, was to reduce the value of S, the solar constant, but those solutions are kind of problematic. We don't really have the resources to do something like that. On the other hand, most real solar radiation management schemes involve changing the value of alpha, the albedo of the planet. We want to increase the albedo and make more solar radiation get reflected away from the Earth, and well, there's a lot of ways we could do that. I mean, for one thing, we could draw inspiration from what volcanoes do. When a volcano erupts, it injects huge amounts of sulfur into its atmosphere. And that sulfur, as we discussed in previous modules of the course, goes through chemical reactions and eventually produces what are called sulfate aerosols. They're actually little droplets of sulfuric acid in the Earth's atmosphere, and as it happens, sulfate aerosols have a very high albedo. And this is why, like, after major volcanic eruptions like Mount Pinatubo in the early 90s, we actually see a global decrease in temperature for a year or two, because all of that sulfur, particularly the sulfur that gets up high in the atmosphere, forms these little aerosols that reflect a surprising amount of shortwave radiation away from the planet. And so we can do this, we can do like a volcano. I mean, a volcano certainly does spew enormous amounts of sulfur in the atmosphere, but in case you've never looked at a, West Virginia coal mine where they're stripping the top off a mountain, frankly, we can take things apart and consume them and burn them too. I mean, we can put that much sulfur up into the atmosphere. It would work. Sulfate aerosols, though, do wash out of the Earth's atmosphere. They are easily water soluble, so if they are in storm clouds and so on, they wash out. So we would need to put them as high in the atmosphere as possible. Most of the weather is in the lowest layers of the atmosphere. But if we could put them up high in the atmosphere, they would last at least on the order of months to years at any given time. But it is true, we would also be continuously replenishing them. This isn't a one-time thing that we somehow inject a few gigatons of sulfur into the atmosphere. It's more like a continuous maintenance kind of plan. We would have to continually be putting more and more sulfur up into the upper atmosphere. But let's not kid ourselves. This is just sort of sweeping the problem under the rug. It is hiding the problem, not fixing the problem. There would still be more and more carbon dioxide in the atmosphere as we kept burning fossil fuels. And if we ever stopped putting these aerosols in the atmosphere for whatever reason, it wasn't politically viable anymore, we couldn't afford it, due to war we couldn't do it, whatever. If we ever stopped putting sulfur into the atmosphere, it would only take on the order of a few years for all the sulfur that we had added to the atmosphere to wash out, and then we would see the global temperatures spike as they would start showing the warming that we had just sort of been hiding. This is not really a solution. Plus, the environmental impacts of sulfur itself are not good. I mean, sulfur is part of the story of acid rain, for example. So we don't really love that option, although it would work and it is being seriously considered. There are scientific papers out there where they examine how much sulfur it is, what size of droplets of sulfuric acid would we be putting into the atmosphere, how long would they last, what level in the atmosphere should we put them in. Real scientists are planning on this to see if this would work. But there are other possibilities. For example, it would actually in many ways be easier to change the albedo of clouds. We actually saw something like this in an earlier module, where we saw how when, like for example, under layers of clouds on the surface, especially over the ocean, if you sailed a diesel-powered ship underneath the clouds, the emissions from the diesel engine made changes in the sizes of the droplets in the cloud and so on that made the clouds have a much higher albedo, and that was called ship tracks, if you might remember that term, where like there were all of these, like here you can see, that's not, I don't know what you might think those fires are or something in that picture. Those are actually just clouds that are over where a ship had been, and you can see that they're much brighter white. They're reflecting more sunlight because of the emissions of the ships. Adding aerosols like those emissions from diesel, but there are other aerosols that work just as well, changes the albedo of clouds pretty dramatically. Now, burning diesel to make that happen is not the most environmentally friendly option. It turns out there's plenty of other aerosols that work, one being sea salt as it happens. And so what's usually envisioned in this kind of plan is something like those kinds of aircraft that they use to fight fires, where the aircraft can kind of swoop down and pick up water from a lake, or from, in this case, from the ocean, and then they would spray that. Now, again, in the case of forest fires, they're spraying it over, a forest or whatever, but this would be spraying that water into clouds to put sea salt into the atmosphere. And this would work. Okay, now, As it happens, it doesn't scale very well for like aircraft to be doing this. It doesn't make sense to have crews out there doing this, but this could be drones, or this could be like solar-powered buoys out in the ocean, although that's hard to picture, where they could somehow like spray the sea salt up into the air. There's a number of different options that scientists and engineers have examined as to how to make this work. But again, keep in mind, this is just sweeping the problem under the rug again. All we're doing here is hiding our problem. If we ever stopped putting the sea salt into the atmosphere, those sea salt aerosols only last in the atmosphere. Their residence time or lifetime is only on the order of a few days. Almost immediately, the warming would be back. This is not really a meaningful solution. Yeah, and so every time we kept burning more fossil fuels all through that time, we would just have to keep increasing the amount of clouds that we're modifying, or increasing the amount of sulfate aerosols we're adding to the atmosphere. None of these are really solutions. They're just sort of us getting onto a new set of problems, you know, where we're going to have to keep adding more and more aerosols to the atmosphere to keep hiding our problems. None of that's so easy and none of that's so great. But there are other ways we can manage solar radiation that are actually kind of cool and low-tech. For example, we could just change the albedo of infrastructure at the surface of the Earth. Like I see a little house there that's from the Bahamas, and its roof is white. Now, in one of the questions that's coming up, I'm going to ask you about why that house's roof is white, but in general, making surfaces whiter makes them have a higher albedo and they reflect more sunlight. Take, for example, asphalt. An awful lot of the United States is covered with asphalt. And asphalt is very, very dark stuff. It has an albedo of about 4 to 12%. In other words, it reflects only about 4 to 12% of the radiation that hits it. If you could just increase this albedo, you would be reflecting a lot more solar radiation up away from the surface of the Earth. And as it happens, a whole lot of the surface of the Earth is covered with asphalt. I checked around a number of different websites online. I got a range of estimates. Probably about 0.2% of the surface of the Earth was a good kind of consensus of the numbers I saw. About 0.2% of the Earth is paved. And so it's paved with these very dark materials that are mostly absorbing sunlight. If we could just change them to materials that reflected more sunlight, or change the color of that so that they were reflecting more sunlight, we could actually meaningfully change the albedo of the Earth. We don't need it to change radically. We don't need to have a big, bright white ball that is the Earth. But the albedo being even a little bit higher would make a difference. Now, in the case of like roads and so on, there are safety issues associated with changing the color of the road. I mean, roads will freeze at different temperatures and different times of day in the winter and so on. There are issues associated with changing roads, but like parking lots and stuff like that, there's no particular reason they couldn't be quite a bit whiter than they are now. Same with, like, for example, in urban environments, roofs. This is just a big old warehouse or something like that, and most of the time, if you look down on a city as you fly over it or whatever, you see that these things are typically covered with like tar paper, and they're black. But there's no particular reason they couldn't just as well be white and be I mean, you know, this building covers an acre or two or something, and it would be reflecting huge amounts of solar radiation back into space. This would really work. All of these solar radiation management strategies would work. The physics is undeniable. They would work. They'd have to be carried out on a large enough scale, but they would work. But that's, you know, they all have problems. I mean, they're only, for example, addressing temperature. But temperature is not the only problem associated with carbon emissions. For example, ocean acidification. This doesn't do anything associated with that. There are other problems. For example, we know that when there are large volcanic eruptions like Mount Pinatubo or El Chichon in the 80s, the changes in the albedo of the Earth's atmosphere due to all that sulfate aerosols largely caused the monsoon in India to be much weaker or even fail that same year. That's really bad news, because about 1 billion people depend on the waters of the Indian monsoon for drinking water and hydroelectricity and irrigation and so on. If we were like putting ourselves into a permanent situation where, guess what, the Indian monsoon doesn't work anymore, that is a major issue that we would have to find a solution for. In fact, in general, the political issues associated with the solar radiation management strategies are awful. We'll talk about those kind of, they fit more broadly into the subject of the drawbacks of geoengineering, so we'll talk about them more in a few minutes. But first, let's do 3 more quick questions. Question 4. Suppose we decided to add sulfate aerosols to the stratosphere, that's just one of the higher layers of the atmosphere, to combat global warming. What would happen if we ever stopped? Now, I'm only giving you 2 options here. Obviously, one should be A and one should be B. I don't know why they're labeled A and A here. The top one is A, obviously the second one is B. A, global temperatures would slowly start creeping upward again over the course of decades due to the greenhouse gases added to the atmosphere after we stopped adding sulfate aerosols. Or B, global temperatures would spike within a few years as the aerosols that we were adding to the atmosphere washed out and stopped masking global warming. Which of those two is what would happen if we ever started the plan of adding sulfate aerosols to the atmosphere but then stopped it? Make a choice from just those two options and get some feedback before you move on to question 5.